broadcast. So SEDAC is talking. Okay. All right. So let's see here.
Thank you everyone to join us for today's webinar. Today's webinar is about the 2018 IECC Commercial Lighting Provisions with corresponding NEC sections. So I think we have most people signed in today, so we'll just go ahead and start. So my name is Sumi Han, and we have here Ryan Siegel too. So both of us are going to cover today's webinar. So this webinar will be an hour long, and then if you have any questions during the presentation, you can type in your questions in the Q&A window on the bottom of the screen. If you hover to the bottom of your screen, you will see the Q&A window. And we'll try to answer your questions during the presentation. If not, at the end of the presentation, or if there are still questions that we didn't have chance to answer, we will make sure to follow up with you with emails. And this presentation is being recorded, so we will upload this recording after the presentation, and also PDF of this slides will be posted to the SEDAC website. So SEDAC, we are an applied research program at the University of Illinois, and we also have a private partner called 360 Energy Group. And our mission here is to reduce the energy footprint of Illinois and probably beyond. And currently, Illinois State Energy Office is an EPA, and SEDAC is providing this energy code training program on behalf of the State Energy Office in Illinois EPA. So we are the training provider for everybody in Illinois, and hopefully some of you are already kind of aware of what we do. So that's our role. And our program, includes many things, not only the webinars like today, but we do have a technical support center. So we have 1-800 number, and we have an email address. So if you have any energy code related questions, you can call us or you can email us. And email is always the best way for code related questions. And also we have a website. If you come to sedac.org/energy-code, we have lots of resources listed on that. And we provide workshops. I think this year we have maybe 7 or 8 workshops so far, and then webinars too. And this is the 3rd one, and then we plan to provide 2 more in the future. And those schedules will be posted to our website. And finally, we do have online on-demand training modules. We have 4 modules developed so far. So we have 1 residential energy code module, and then 3 in commercial, envelope, lighting, and HVAC. So if you don't have time to come to our workshop or have hard time to tune in for the webinars, you can always sign up for this online training. And if you can recommend this to any people who are kind of new to energy code, like this is designed for the beginner level, people for the energy code training. So it is free and open to everybody. You just need to sign in, and there'll be some quizzes at the end of each online modules. And if you pass more than 70%, then you will get the certificate. And this is how our energy code training program website look like. And then on the left, you will see the menu. It includes FAQ and then resources and schedule for workshop and webinars. So please come and visit this website to get to update on energy code related issues. So I think many people are very interested in finding out when would be this new Illinois Energy Code will be effective. And until like last week, we've been saying that March 1st is the anticipated date for the updated code, which is based on 2018 IECC. And we have a new information. And now, based on our information, that our best guess at this time is May 1st. So, of course, this isn't, as you can see, there's a question mark. So this isn't 100% confirmed because it depends on some procedural things. But this is our best guess, and March 1st will not be the effective date. That is for sure. But when? May 1st. That is the best answer that we can provide at this moment. So 2018 IECC, there's a physical, the copy of the book, but also there's a web version of the code. So if you want to have access to 2018 IECC code, you can come to this, you can click this link, or you can come to SEDAC website, and we have, listed all the links that related to Illinois amendments or 2015-18 ICC. So feel free to use these links. So if you come to this link, you will see the web version of the code, and you cannot copy or paste, but you can actually browse through using the search function. So if you have a keyword that you want to know, then you can type in the search, and then it will highlight. So it is very useful tool for you to go through the 2018 ICC. So today we are going to talk about mainly lighting. So in terms of commercial lighting, C405 is the major section in IECC that talk about lighting. And there are, mandatory provisions and, prescriptive provisions too, but mandatory provision meaning that no matter which compliance path that you are taking, you need to comply with these mandatory provisions, which include, something about the general, like in terms of like a dwelling units and, sleeping units, what kind of lighting requirement you need to do, and then lighting controls. That's mandatory provisions. And then another mandatory provisions in the C405 is exterior lighting power requirements. So major highlights of that C405 section regarding the lighting is number one, the LPD, lighting power allowances have gotten reduced. I would say maybe 15 to 30%. It's not a drastic change, but it is definitely a reduced allowance compared to 2015. And then there's a new choice of the control requirement. It's called luminaire level lighting controls. So now you can kind of meet the mandatory lighting control requirement by doing traditional control, but also you now have a choice of using the luminaire level lighting control, which is the lighting fixture that has the integrated control component to it. And then there are more, mandatory requirements in terms of lighting. So more and more, there are like a tighter requirement and mandatory standard for the lighting control. And then there's a automatic lighting shutoff for the interior lighting. And then also for most of those lighting control, there gotta be manual override switches for occupant sensor control or time control. Those all needs to have manual override switches for occupant to override. And then daylight responsive lighting control. It was there before, but now it has more detailed requirements. And then there are some languages and special applications that is for like there are some applications that are listed under here that is new in 2018. And then exterior lighting control, a little bit more stringent. And then there are some like admin or definition or just some language changes to clarify the code requirement in the C405 sections. So other than C405, there are other sections that talk about commercial lighting related requirements. And one is C463. And that's, so one is about the additional energy efficiency options. So if you comply with the 2018 IECC Energy Code, if you choose to comply with a prescriptive path, then you need to comply with all the mandatory requirements, plus prescriptive requirements, plus you need to pick at least one additional energy efficiency options that is listed in section C46. So there are so the efficiency packages there is more efficient HVAC performance or reduced lighting power, enhanced lighting control, or on-site supply renewable energy, and dedicated outdoor air system, and high-efficiency surface water heating. So those were already there in 2015. And 18, there are two more efficiency packages that are added, which is the enhanced envelope performance and reduced air infiltration. So there are two lighting related additional efficiency package that you can choose from. One is reduced lighting power. So if you have less than 90%, then the building area method or space by space method allowed, then you are meeting this additional efficiency package option. Or you could choose enhanced digital lighting control, which has all this requirement that is a little bit, complicated, but it's achievable. So if you choose to pick this as your additional energy efficiency options when you comply under the prescription path, then here are the requirements that you need to meet with. And another highlights that we want to mention is that the functional testing of lighting control, not only like have the lighting control that has the ability to control the lighting fixture, that there are some languages that require that you need to meet with to make sure those are actually working properly. So prior to the inspection, then you need to make sure that fixtures and control and all the hardwares that are related to that needs to properly function. So you need to do the testing. And then second thing that we want to also highlight is that there are requirements for documentation. So construction documents should include drawings that indicate the location and catalog number of each lighting control equipment. And manuals and report should be provided to the owner within 90 days of the receipt of certificate of occupancy. And those manuals should include the name and addresses of a service agency for the control, and then narrative of how each system is intended to be operated, and submittal data, and then O&M manual, and then schedule for inspecting and recalibrating all the controls. So those information should be included in the manual. And then report is about the functional testing. This report should include the test result of the functional testing. And then if something didn't work properly, you need to write it down. And then it also needs to include how that could be corrected. So those are the requirements in terms of lighting control. So now we are going to talk about some item by item in the section 405. So in 405.1, it's talking about a general requirement. So here, dwelling units within multifamily buildings need to follow R404.1. And then see, we have R as a red because now so today we are talking about the commercial lighting, but if you have a dwelling unit within commercial multifamily buildings, then you need to follow the residential code R441. All other dwelling units in commercial building, you have an option. You can either follow R441 in residential provisions, or you can follow C405.2.3, which is specific application control, talking about dwelling units, and C405.3, which is the interior lighting power requirements. And then third, if you have sleeping units like hotel and motel, you have options. One, you can meet the requirements of C405.2.3 and residential section of R404.1, or you can meet with C405.2.3, which is specific application control on sleeping units, and C405.3, which is the lighting power requirements. So because we just briefly mentioned that you could actually use R section for some of the dwelling units, we will just briefly mention that about the residential section of the lighting requirement. So R441 is a mandatory section in residential provisions. It says not less than 90% of permanent lighting should contain only high efficacy lamp. In 2015, it was 75%. Now it has increased to 90%. And it says high efficacy lamp. So according to the definition of 2018 IECC, the definition of high efficacy lamps are as shown. Like it has different categories for like if the lamps are more than 40 watt, this is the high efficacy standard. If its lamps are less than 15 watt, this is a high efficacy lamp standard. But the Illinois has its own amendments, and this section is amended. Well, it's not confirmed because the new code is not effective yet, but it will be changed to the fixtures. So high efficacy lighting, the fixture should be more than 55 lumen per watt. And for the lamps, it should be more than 65 lumen per watt. That's the definition based on Illinois amendments. So that's different from IECC's definition of high efficacy lamps. So you should be aware of this if your project is in Illinois. So about the lighting control. So you can choose to comply with the requirements under traditional lighting control requirements, or now you can use this LLLC, luminaire level lighting control. And luminaire level lighting control has 3 sections that needs to meet, which is occupancy control, and then specific application control, and then manual control. And on top of that, LLLC should be independently capable of these requirements. The first one is, about the dimming control. Second one is about the daylighting control. And third one is this luminaire level lighting control should be able to be configured and reconfigured performance parameters, including the dimming set point, timeout, wireless joining capabilities. And then occupant sensor control. So the new thing in 2018 IECC in terms of occupant sensor control, open plan office area is included in the occupant sensor control required area. So other areas were already there in 2015 IECC. Slight changes, something like warehouse. In 15, it says just warehouse. Now it says warehouse storage areas. And under the occupant sensor control, there are some requirements for what kind of function that occupant sensor control should have for different types of area. And one is warehouse. So the requirements for the occupant sensor control in warehouse, it should reduce lighting power by at least 50% when there's no occupants there. So 50 or more. And then the control should cover the aisleways and open areas, but then it should be separately controlled. And then each aisle also needs to be independently controlled by the occupancy sensor. So the picture here shows that on the right that only like one aisle is on. So it is separately controlled from other aisles or the general area. And then second area that has some detailed requirement for the occupant sensor control is open plan offices. So open plan offices that is larger than 300 square foot should have occupant sensor control. And you need to make sure that zones, the control zone, cannot be larger than 600 square foot. So, it will not make sense if you have a huge open space, open plan office and has one occupant sensor control to control all the lights in there. So that's what it has the limitation on the control zone as 600 square foot. And then the occupant sensor control in open plan offices should turn off general lights in all zones within 20 minutes, not 30 minutes. It was 30 in 2015. So it should be turned off within 20 minutes after occupant leave. And then the control should reduce lighting power at least 80% within 20 minutes after no occupancy, meaning it could turn off, but you could have it dim it down to 20%, reduced by 80%. And then daylight control should be activated only when occupants are present. So if there's nobody, the daylight control should not trigger the light to turn on. And what about other areas other than warehouse and open plan offices? Those areas that require to have occupant sensor control, that should have auto off within 20 minutes after occupant leave, and then it should have manual on, or it could be auto on if not more than 50% of power is being used. And there are some exceptions to this requirement, as you can see, mainly for the safety reason. And then other requirement for the occupant sensor control in other areas, it should incorporate a manual control. So if there's occupant that needs to turn on for some reason, they should be able to, turn off, they should be able to turn off the automatically turned on lighting. So those are the requirements for the occupant sensor control in all other areas, but warehouse and open space offices. And then time switch controls. So time switch controls are required at all the areas that do not have occupancy sensor controls. So it's either it has occupancy sensor control or time switch controls. And the exception to this time switch control requirement, as you can see, those are mainly for safety or the patient care area. And then time switch control should have these functions. Each space should be provided with manual control for light reduction in accordance with this section. So it has a requirement for the manual control for light reduction, the C405.2.3.3. So each space that has time control should have manual control for light reduction. And time switch control should comply with these requirements, which are basically have a 7-day, the daily schedule, and then should have a holiday shut-off function, and then should have at least 10 hours of program backup if power is discontinued or disrupted. And time switch control should have override switch, and that override switch should be manual, and override cannot be more than 2 hours. And then individual override switch may not cover more than 5,000 square foot. So light reduction control that we just talked about, that time switch control should have this too. So manual control, it should allow occupants to reduce lighting by at least 50% or more in reasonably and in uniform pattern. So you can see the picture on the bottom. So you could, reduce the light by dimming, so all the fixtures are equally dimmed to meet certain level. And then the second picture shows alternating luminaires. You could have like every other fixture off, or the other half on. So it's kind of spotty on the ceiling, but it may work for certain application. And then the last one is alternating lamp. If the fixture has multiple lamps, you can alternate. So either of, any of the way, if you could reduce the total light by at least 50%, then you could meet this requirement of manual control. So now we're going to talk about daylight responsive control, and Ryan is going to take over from here.
Well, thank you, Sumi. So daylighting controls, these are required in spaces that do have either sidelit through windows or other fenestration, or toplit zones, which may include things such as skylights or clear stories. And so they do require this for spaces that have more than 150 watts of power or lighting power in these zones. There is some exceptions through here. One of these can be very useful for many projects. Obviously not a whole lot of facilities are healthcare facilities or specific application controls. The last exception is actually a very potentially a very useful one that we'll talk about a little bit later, as far as using reduced lighting power to no longer require daylight harvesting controls. As far as calculations, we won't go too deep into this, but you have to know what counts as a watt for your calculations as far as how much lighting power you have. It's the sum total of the luminaires, the ballasts, LED drivers, track lighting, as well as any other things that are not covered in the other sections. Now, as far as mentioned about the lighting power for daylight harvesting, if you reduce your lighting power by at least 40% of the weighted area that is in the daylit zone, you don't have to have additional daylight harvesting controls, because by installing less power density, you are getting the savings through better lighting design rather than adding additional controls. So as far as what this might look like in our first example on the left, you can see that for this example, we've got 50% of our daylit, or of our total square footage, is in the daylit zones. So 100,000 divided by 200,000 gives us our 50%. And so being the 40% of the weighted area of the 50%, that means if I reduce my lighting power by 20% or more of the budget, then I don't have to do daylight harvesting controls. In the second example, here we have a smaller daylit zone where it's only 50,000 square feet of a 200,000 square foot building. So it's a quarter of the space. So if I take 40% less and I need a quarter of that, so if I can reduce my lighting power by 10% across the whole building, I now take advantage of that exception. This is one very beneficial thing, because if you have this exception, or you make use of this, that's daylight harvesting controls that you don't have to buy, you don't have to install, and you don't have to commission. As far as certain control functions that must be part of daylight harvesting controls, obviously noting toplit and sidelit zones have to be controlled independently of one another, because the amount of daylight that is coming in from top lit versus side lit is likely to be different. And noting here, the fourth bullet down, noting that we'd want this to be dimming continuously for certain areas, specifically offices, classrooms, laboratories, and libraries. Other spaces may have step dimming, but in these spaces, step dimming can be rather disruptive to the environment. And so that's why the code requires continuous dimming for these. Daylight harvesting does have to be able to completely turn off lights in the event there is adequate daylight. Many people have likely experienced being in a very bright room, and then you still have the lights on, even though they're not being very contributive to the overall lighting environment. Side lit, we noted earlier, top lit and side lit have to be controlled separately. Similarly, side lit zones facing different cardinal orientations need to be controlled independently. Now, they do provide an exception to allow some overlap. This would be for corner spaces and things of that nature, where you might have north and east facing windows in a single office. One thing that the code does very well is they provided some very nice depictions as far as how to calculate the zone areas, and noting that for side-lit zones, you have to have windows that are large enough to qualify as side-lit areas. Windows that are less than 24 square feet or have extreme tinting on them would not qualify as a side-lit area. And these depictions are also in the online version of the code. So again, we would refer you back to that for further clarification and assistance with trying to help draw out where those areas are. This is what it might look like on a set of blueprints. This is at a school. Now here you can see that the shaded areas are my side-lit zones. I don't have any skylights in this building, so I don't have any top-lit zones. But it is not uncommon for designers where they'll have a set of sheets that indicate the side-lit zones on a lighting print and a separate print without the shading for clarity of viewing. And this is something that is required, that you identify the side-lit and top-lit zones on the drawings. As far as top-lit zones, and again, the code goes into a couple of different methodologies. Here showing a skylight. They do have other ones for roof monitors and other top-lit type of zones. And here they do provide some provisions for if you have buildings that have blocked direct sunlight during this peak times, that you don't have to have the top-lit zone controls, purely because it wouldn't be of any benefit since the buildings may be in the shade through a substantial portion of the year. As Sumi had talked earlier, there are some specific application controls that are required for lighting controls. One of these is for display and accent lighting, obviously in your display cases, supplemental task lighting, so your desk lights, and lighting equipment for sales or demonstration. So they do have provisions to not require controls for occupant, sensor, or time switch, but they may also require specific manual controls separate from the general area lighting. Sleeping units, we're now seeing these in more and more locations, hotels and motels using key card for sleeping units in lieu of occupant sensing controls that are required to turn it off 20 minutes after there is no longer an occupant sensed in the space. Beyond the keycard controlled switches and receptacles, they also do have a exception, again, where patient care is directly provided. For dwelling units, they do have specific requirements for occupant sensor controls. Again, these are dwelling units inside of commercial buildings. And also there are provisions for non-visual applications. Here depicted plants and food warming. So this would be use time switch controls that are independent of the general lighting. You know, one might imagine where a restaurant, if these heating lamps were controlled by the general lighting circuits, then these warming lamps would be on, you know, from before the restaurant's open till after it's closed, even though there's not likely to be any food present during these times. So as we switch from automatic controls over to manual controls, some of the provisions the code has is that manual controls must be, that occupants must have ready access to these manual controls. And secondly, that they are located where the lights are visible or need to be identified as to where the lights are that these switches are controlled. If you can imagine a bank of switches in this picture, you know, at a front desk where you may be controlling switch lighting that's in the far back reaches of a building. You want to be able to know whether those lights are on or off. As far as exterior lighting controls, there have been substantial changes in this area as far as decorative lighting, and which includes facade and landscape lighting, to require not only daylight shutoff, but also time switch function. Previously, a lot of the exterior lighting controls required either daylight shutoff or time switch function. New codes are now requiring it to have both functions. Decorative lighting also has requirements for shutoff during non-business hours, and exterior lighting is required to have lighting setback of at least 30% during these non-business hours. And it does provide some guidance as far as a couple of different options for determining what that time frame is. Noting the daylight shutoff, this is the one that's the most common. Decorative lighting shutoff, here noting that's within 1 hour of business. And the lighting setback, here's the three options. It can either be from turned off from midnight to not early than 6 a.m. or within 1 hour of business, or you can use an occupant sensor and you turn the lights off when there is no activity for it for greater than 15 minutes. So, time switch control provisions here are the same as interiors, which includes 7 daily different schedules, holiday setbacks, and program backup capability of at least 10 hours. As we move over to interior lighting, you can choose either the building area method or space by space method. This does have some additional allowances for special use lighting particularly sales areas. And this fits very nicely with the National Electric Code, which allows for a reduced load calculation if you do provide some power monitoring of these lighting loads, given your building is within an energy code jurisdiction, which any building in the state of Illinois would be under this for commercial and residential permitted buildings. The building area method covers broad categories. This is the more simple type to use. It's a gross square footage times the allowable watts per square foot to give you your budget. So you can split building type areas. So you may have a dormitory with an attached performing arts center. That could be a possibility, for a college campus. And so you can segregate these large categories of square footage. You'll see here that, as Sumi mentioned, there's a slight decrease in most categories. Lighting technology continues to advance and become more efficient. One place that it did increase is in dormitories, which is why it's bolded there. It's a nominal increase there. One of the largest categories that we've seen a decrease has been libraries. They saw a dramatic reduction of almost a third. Now, this also shows a comparison between the IECC tables and the tables found in the National Electric Code. Here you can see for a school, National Electric Code calls out 3 volt amperes per square foot as compared to the IECC's 0.8 watts per square foot. Now the NEC does account for some plug load in their 3 watts per square foot, but as you can imagine, that's still rather substantial with having over 2 watts per square foot of plug load available and accounted for in the NEC. As noted earlier, if you do have some monitoring of the lighting, you can actually do a reduced load calculation for the National Electric Code to prevent some of the equipment oversizing that may otherwise occur. If you do find yourself needing an alternative to the building area method, you can use a space by space, and these are much more specific and can be traded between the spaces except for some of the additional lighting allowances, specifically sales areas cannot be traded to the general area. So this kind of gives you a rough or a snapshot as far as what some of this is. A healthcare clinic would be through the building area method of 0.82 watts per square foot, and a hospital would have a budget of 1.05 watts per square foot. So as you can see, that you might be able to get some benefit by using the space by space method as compared to the building area method. However, your calculation becomes much more complicated, as rather than a healthcare facility just having a single calculation, here there's at least 8 different spaces that would have to be allowed for. This is some of the trade-off specifically for sales. Obviously, the smaller the item, typically the higher the wattage of additional allowance, with the highest going to obviously your crystal, jewelry, and china. Noted earlier about determining the connected load. One of the big changes in the IECC with the 2018 version has been in the track lighting. The base allowance for track lighting is now down to 8 watts per linear foot, whereas previously it was 30 watts per linear foot as a base allowance. Now, if you do have more than 8 watts per linear foot of connected load on that track, then you do have to use that, the actual connected wattage, and not just the 8 watts per linear foot. I compare the IECC's 8 watts per foot to ASHRAE 90.1, which uses 30 watts per foot, and the National Electric Code that is 75 watts per foot. So that's a rather dramatic difference between these three. As we move over to exterior lighting, they break it into 4 zones. Zones 1 and 4 will be used very infrequently. Most areas will be zones 2 or 3. Zone 4 would only be found within the city of Chicago, in the state of Illinois, and would have to be designated by the local land use authority as being in the high activity commercial zone. So most everything you're going to find is in zones 2 and 3. Not surprisingly, as you move into more and more dense population, the allowances increase. So with zone 4 being the least restrictive and zone 1 being the most restrictive. Again, zoning 1 being your parks, your national and state parks type of facilities. I will note that on the table in this section, there is an errata where after the first printing of the 2018 code book, there was an update, or there was some typos made to the table C405.4.2.3. So check those errata for the updated wattage for that table. For this is some additional lighting exterior. This is not tradable with the other exterior lighting. So you're building facades, ATMs, inspections, and the like. So here, looking at a drive-up ATM and bank drive-up windows. So this example here, I've got one ATM, so I'd get 135 watts for that lane plus 200 watts per drive-through. So that, for this example, I've got 135 plus 2 times 200 for a total allowance at this canopy of 535 watts of connected load I could have here. Now, if these were all 3 ATMs, then it would be 135 plus 45 times 2, or a total of 225 watts of connected load. Now, we are focused predominantly on the IECC because that is what we find most people use. ASHRAE 90.1 has a couple of unique situations, which is why we seem to more people lean away from it. And the two predominant things are automatic receptacle controls and electrical energy monitoring. Normally, ASHRAE 90.1 is used only if a client requests it, or for semi-heated spaces. Now, the state of Illinois previously was required to use ASHRAE 90.1. With this update cycle, they're going to be gaining flexibility to use either IECC or ASHRAE 90.1. The automatic receptacle control requires at least 50% of the 15 and 20 amp receptacles be controlled, and they must be marked permanently to differentiate controlled and non-controlled, and you have to distribute them uniformly across the space. So this is a depiction of how some of those receptacles might look. The white receptacles on the left and right, that is, both receptacles are controlled. And in the blue receptacle in the middle, the upper receptacle is controlled and the lower receptacle is not. So you can either have it where, in the case of those white receptacles, there might be a second receptacle beside it that is not controlled to provide your 50%, or you might use one like the blue one to get your 50% where every other plug is controlled. Electrical energy monitoring, this is the other piece that's found in 90.1 but not in the IECC. One thing that we do look at is this provision may seem onerous by having to segregate your loads. However, we could see for troubleshooting, this would be a very beneficial thing to have your loads segregated to see, you know, is my exterior lighting controls working or not? Do I have interior lighting that's being left on overnight? Do I have some problems in my heating and cooling equipment? Do I have a heat pump that's not working and causing electric resistance heat to be used when it shouldn't be? So this could be a provision where this may be useful to a building owner, even if not required by the IECC. So, with that, I want to thank everyone for attending today's webinar. For those that may have questions, feel free to reach out to us either through our email address or through our phone. If you do have a question today, I would invite you to use the Q&A function. If you float towards the bottom of your screen, or your mouse towards the bottom of your screen, you should get a Q&A selection that you can choose and provide any questions that you may have today. We do have a question here regarding our professional development hours. We do offer professional development hours for BPI as well as the Association of Energy Engineers. So we can provide that information to you if you need. Feel free to reach out to us again at our email address if you need something specific, energycode@sedac.org. Question regarding the National Electric Code here, and noting the differences between the Energy Code and the National Electric Code. That would be part of, yes, calculations for feeder sides, as well as any other associated electrical equipment that would likely be tied in with. I do want to let people know about our next webinar, which will be on commercial HVAC equipment. So we'll provide that coming up. That will be later on in the spring, and we will have more information about that again at our website, as well as also in our newsletter. So we will make sure to touch on the exhaust air energy recovery requirements during that webinar, which is scheduled for April 17th. Again, April 17th, commercial HVAC requirements, and that will also be at noon. So again, want to thank everyone for attending today's webinar. And again, if you do have any questions between now and our next webinar, feel free to reach out again, energycode@sedac.org. Thank you and have a great day.